What's up, everybody? This is Mr. Richardson coming at you live through the power of the internet. What we're going to be doing in this video is solving quadratic area problems. If you're just making it to this video, make sure that you hit the subscribe button so that you're up to date on all of the latest math videos I post here. Before watching this video, make sure that you go back and watch some of the previous videos on factoring to get you caught up and ready to solve quadratic area problems. When we're talking about quadratic area problems, you're trying to find the dimensions of a rectangle, particularly the length and the width. These problems are a little bit more challenging than you might do for a regular quadratic problem because you kind of have to set up an area problem. Well, if we're talking about the area of a rectangle, you're always going to be using this formula, that the length times width equals area. Then all we need to do is plug in the appropriate information and it will turn into any other quadratic equation that we've tried to solve. For the length here, you could either plug in x minus 8 or x plus 3. It doesn't matter which one you pick. For the width would be the dimension you didn't pick, and the area here is given at 26. When I want to solve a quadratic equation, the whole goal is to get it equal to 0 so that you can apply the zero product property. In this case, it doesn't equal 0, it equals 26, so eventually we're going to have to get this to equal 0. Of course, I don't want to subtract 26 yet because there's a product on the left-hand side, so there's nothing to combine it with. So our first step is going to be to FOIL. X times x will give us x squared. X times 3 will give us 3x, negative 8 times x is negative 8x, and negative 8 times positive 3 is 24. Bring down the equals 26. Now we can combine like terms that are on the same side. Here, negative 8x and 3x would combine to negative 5x. Now we're in a scenario where we can almost get this to equal 0. We have this constant of 26 that's always been on the other side. We can finally go ahead and subtract that. It will combine with negative 24, and we would get negative 50. Now we have a quadratic equal to 0. Of course, we want to do zero product property, but we can't do this until we factor. So this is trinomial factoring, which we know is always factors like this, but we just have to find the numbers that go in the blanks. Here, those two numbers will always multiply to the c term and add to the b term. In this case, they multiply to negative 50 and add to negative 5. Anytime two numbers multiply to a negative, we know one number has to be negative and one number has to be positive. In this case, those two numbers are negative 10 and 5, which I'll put in the blanks. Now we can finally use the zero product property, setting each of these factors equal to 0. To solve the equation on the left, simply add 10 and I get x equals 10. To solve the problem on the right, simply subtract 5 and I get x equals negative 5. Now, one thing that makes this problem different from others is we get two solutions here, and we actually don't need both of these x values. Remember that we're trying to find the dimensions of a rectangle, and when you're talking about dimensions, they have to be positive numbers. Maybe the length of the rectangle is 15 feet. It couldn't be negative 15 feet. That wouldn't make any sense. So in this case, we can forget about or reject this x equals negative 5, since that won't give us any positive dimensions. If I was to plug negative 5 in here in the equations, I would get negative numbers. So 10 is the only x value that we'll need, and now we can actually find the dimensions. Plugging 10 into this first expression, 10 minus 8 would give us 2 feet, and 10 plus 3 would give us 13 feet. So these here are the two dimensions, 2 feet by 13 feet. To check my answer, simply multiply those numbers and see if they give you the correct area. When I do length times width, or 2 times 13, you can see that you get 26 feet squared. Let's try one on our own. See if you could find the dimensions of this rectangle. What you're going to notice about these problems is that they're very repetitive and very similar. You may struggle with them at first, but after you practice a few of them, the process keeps repeating. First step is to write down your area formula. Length times width equals area. Plug in the dimensions. When I plug in those dimensions, one of them is x minus 3, the other dimension is x plus 5, and that equals 20. Now we need to FOIL or double distribute so that this goes from factored form to standard form. When I FOIL this, x times x would give us x squared, x times 5 would give us 5x, negative 3 times x would be negative 3x, Negative 3 times 5 would be negative 15. Bring down the equals 20. Now we want to combine like terms on the left side of the equation. Positive 5x and negative 3x gives us 2x. Now we have an equation, but it's not yet in standard form because it equals this constant, and we know that we want it to equal 0, so subtract 20 from each side. When you do that, you'll have x squared plus 2x minus 35 equals 0. At this point, we have an equation in factored form, but or we have it in standard form rather. We want to put it in factored form, so we'll use trinomial factoring. You need two numbers that multiply to negative 35 and add to 2. We know that when two numbers multiply to a negative, one number has to be positive and one number has to be negative. In this case, you get positive 7 and negative 5. Put the trinomial into factored form and apply the zero product property. Solve the equation on the left by subtracting 7. We'll get x equals negative 7. Solve the equation on the right by adding 5. We get x equals 5. 5 and negative 7 are answers to this equation here. However, both of these do not answer the problem. What we have to do here is reject the negative solution because we can't have a negative dimension and use 5 to find the correct dimensions. We're going to plug 5 into both of these expressions. 5 minus 3 will give us 2 feet. 5 plus 5 will give us 10 feet. Our final answer is 2 feet and 10 feet. To check our answer, simply multiply 2 feet by 10 feet to see if you get 20 feet squared, and you do, so this is correct. Let's try another. See if you could find the dimensions of this rectangle. First step is to set up the area formula. For a rectangle, it's length times width equals area. Next step is to plug in the appropriate length, the appropriate width, and the appropriate area. Next step is to double distribute or FOIL. Now we need to combine like terms. Negative 3x and negative 2x will give us negative 5x. Now, of course, we need this to equal 0, so subtract 30 from both sides. Now we need to factor. This is trinomial factoring. We need two numbers that multiply to negative 24 and add to negative 5. We know that when two numbers multiply to a negative, one will be positive and one will be negative. Here we get negative 8 and positive 3. Take this from standard form and put it into factored form. Apply the zero product property. Solve both equations. Reject the negative dimension. And use the value of 8 here, the positive value, to find out what the actual dimensions are by plugging them into the expression. 8 minus 3 would give us a dimension of 5. 8 minus 2 would give us a dimension of 6, meaning our length and width are 5 feet and 6 feet. Finally, to check your answer, multiply 5 feet by 6 feet, and sure enough, we do get the correct area. See if you could find the dimensions of this rectangle. First step is to set up the area formula for a rectangle. Length times width equals area. Step 2 is to plug in the appropriate dimensions. For length, I'll plug in x minus 4. For width, I'll plug in x plus 5. And the area here was given at 90. Next step is to FOIL, or double distribute, the left-hand side of this equation. You'll get a result of x squared plus 5x minus 4x minus 20 equals 90. Combine the like terms. Subtract 90 from both sides so that this equation equals 0. Now we need to factor. Here I'm looking for two numbers that multiply to negative 110 and add to 1. Sometimes when this c value gets very large, it can be difficult to find the numbers. Maybe you don't know factor pairs of 110 off the top of your head. But one thing I can also look at is the b value. In this case, the b value is 1. When the b value is 1, I know that the numbers are consecutive or just 1 apart. So I think of numbers that are only 1 apart that will multiply to 1 in 10. Like 3 and 4, those are 1 apart. Do those multiply to 1 in 10? How about 8 times 9? Those are 1 apart, but 8 times 9 is only 72. The appropriate numbers here will be negative 10 and 11. Now take the equation from standard form and put it into factored form. Use the zero product property. To solve the equation on the left, add 10 to both sides. I'll get x equals 10. To solve the equation on the left, subtract 11 from both sides. I'll get x equals negative 11. We can reject the negative value here as it won't give us a positive dimension. Here we'll use the positive value in both of these expressions to figure out what the dimensions are. 10 minus 4 will give us 6. 10 plus 5 will give us 15. And our dimensions are 6 feet by 15 feet. In order to check this answer, simply multiply 6 feet by 15 feet to see if you get 90, and you sure do. Let's try one final example. See if you can find the dimensions of the rectangle shown below. The first step is to write length times width equals area, our formula for the area of a rectangle. Now we plug in the expressions for each dimension. The length was given at x minus 10, the width at x minus 7, and the area at 130. Now we can FOIL or double distribute, combine like terms. Subtract 130 on both sides to put this into standard form. Now we use trinomial factoring. Find two numbers that multiply to negative 60 and add to negative 17. Take this from standard form and put it into factored form. Use the zero product property. To solve the equation on the left, add 20 to both sides. To solve the equation on the right, subtract 3 from both sides. Reject the negative x value. And finally, find the dimensions by plugging the positive x value into the original expressions. 20 minus 10 will give us a dimension of 10. 20 minus 7 will give us a dimension of 13. And of course, 10 times 13 is 130 feet squared. I hope this video helped you learn how to solve quadratic area problems. Until next time.